Hi, I'm live. Let me quickly share the screen and we'll see the agenda of this stream. What will keep the name of the file intro to Kafka? So this is the most familiar name. Um, this is the most familiar name, Kafka. I think many of us who are into software engineering uh, in the some or other point of time would have listened this name, would have heard this name, or if you haven't, maybe in future you are going to hear this name. So, what is Kafka? This is very cliche way of getting introduced to a topic, right? Let's say the topic name is Elasticsearch. The usual like how we'll see is we'll directly jump onto the definition, and it tells a random thing like okay. For clarification, let me tell you what is Kafka. Kafka is a event streaming platform. This is a simple definition. And do we actually understand? I read the definition. I approached this topic in multiple ways where I can actually start understanding this. But yeah, this is a definition I see. Like, see this definition, right? If you see this definition, it's like what is Kafka? Kafka is event streaming platform. Like there are so many unknowns in this. In fact, nothing is known in this. Like what is event, what is streaming? We know the platform, but what does platform refers to? Does it is it a web page, or is it a backend server, or is it some GPU, CPU? What is it? What is platform referred to? So, and I tried multiple ways of approaching this topic, approaching this topic itself, and I found this very useful, right? Like because at my current organization, Kafka is one of the most used thing in developing building solutions. So before that, if we see like this, why we need Kafka? Like why do we need it? Like if you say something, you need to justify why. Say you said this. If you say this is the most optimal, shortest path algorithm, you should tell why this is the most shortest path algorithm instead of explaining uh, what it is. Like you know the difference, right? Always why should come before what. Yeah. So why we need Kafka? Before that, let's see a small example of. Before that, let's see a small example of how you. I'll bring up a scenario. Okay, whiteboard. Ouch. This is a bit different. Okay. Okay. No, this is too much. No, let it be dark. Yeah. Now it is good. Let's erase this. Okay. Before telling this scenario, let me confirm once with Okay, it's still no need to confirm. Let's see if this is wrong. I'll also learn from this. So let's say there is a food delivery system like this, right? Scenario. There is a food delivery system where you place order, your payment gets accepted. You place order, your payment gets accepted. You will be allotted a maybe delivery boy. I don't know exact name. Sorry. You'll be allotted a delivery boy. Um, your food will be picked up by delivery boy. Your food will be delivered to your address, and all these steps are trackable. Okay, is there a word called as trackable? I don't know, which means you can see these immediate steps, right? Like if you place your order, you can see that bike going in the map lively. So again, I'm not a big spelling guy, so don't expect the correct spellings. So yeah, these are the steps that happens when you order a food, right? So let's see how this, like, how do you um, you know how does it happen? So this is UI. Nice. This is so good, man. No, this is UI and order microservice. I just want microservice to be in same line. This is your UI and this is your order microservice, and this is your payment microservice. My God, what happened? Okay, this is your payment microservice, and I am actually bad at it, and I don't know if this is a proper design or not. I even don't know how to do this. Let's just let's say this is delivery microservice. Microservice spelling is right. Yeah. Say this is a delivery microservice, and there is one separate service which notifies to you, called as notification service. Okay. As I successfully scared you guys with the word microservice, let me rename this also to microservice. Yeah. Yeah. So let's say this is a UI. From the UI, you place order. Whatever you do, it gets picked up by order microservice, and it sends to payment microservice. When your payment is successful, it will show to you. Let's how to draw lines in this. Okay. So say you made payment, and after you made after you placed click on place the, like, after you click on um, say, assume you are paying, right? Assume you are paying, and the UI. Okay, my bad. Assume you are paying and okay. Okay, I think assume you are paying this and yeah. So once you paid, so this microservice gets um, takes care of payments, like whether your payments is successful or not. In response, again it send back a in response it sends back a response saying that okay, payment is successfully done. This should be arrow. Yes. How this is so good. Like this is a request, status of payment. This is a response. This is the request and this is the response, right? Now, once if you are successful, like if payment is successful, you will be given a button saying that place the order. Once you place the order microservices will need to find a delivery microservice. I end it here. Order microservice will attach it to delivery microservice, and delivery microservice will listen to this, will say that okay, this order has been received. And this what this delivery microservice does is, imagine like it finds nearest delivery person to you and restaurant to you, and it does that. Okay, once this delivery guy picked up, you'll be seeing food is getting prepared, or the delivery is on the way, or delivery person in the restaurant, he's picking the food. Then you will be notified to a notification. Let me draw this quickly. Even I haven't planned about this. Okay. Mm, let's go here. Let's draw a mark for this. Okay. Yeah. Um, wow, this is such a cool thing. Yeah. Now, oh, sorry, my bad. Yeah. So, order microservice take care of this, and payment will take care of this, and order microservice will send that okay, order has been placed to delivery microservice. Delivery microservice will does the restaurant identification and do that, and you'll be getting notified, right? So you'll be getting notifications. And we don't want normal notification, right? um, We don't want normal notifications. We want the step by step phase of like whatever is happening there. So if you see this, this is seem, even though this is, I don't know whether it's the correct design or not, but for this system, imagine the workaround you have to do. So let's say if 20-30 users are placing orders, and this order microservice need to tell this delivery microservice that okay, orders is been placed, now it's your duty to take and keep routing it to keep finding delivery and stuff like that. But what happens here is, say okay, I don't know why it is moving. Okay, say let's say if since this delivery microservice has to be worked, this has to continuously listen to it always. Maybe a different polling mechanism like long polling or short polling. Does orders are placed? Does orders are placed? Does orders are placed? And this is a request, and again this is a response, right? I don't know how to get. Yeah, this is a request saying that order came, order came, order came, and there will be a response. This is request and this is response saying that okay, order came, or order not came, something like that. But these connections are very expensive, and this might cause to miss some of the microservice, some of the orders. Same with notification system. Always notification system cannot, keep giving you live updates, because it should be here to it should be hearing this to this delivery microservice saying that did request response came, and my bad, sorry. Okay, this is a request. This is a response again. Again, this is also a request response, and this is a completely messy thing. This is also called as spaghetti architecture. Imagine the logic or the type of, let's say you have a server here, like which will be responding to this. Assume this order microservice there is a server, and it will be telling okay, order is accepted. Then delivery microservice should keep sending request to that server saying that what is the response, and it gets response saying that okay, this is delivered. And the same thing whatever is happening here will again happening to this. And yeah, like you can understand why this is called as spaghetti architecture, because it's entirely messed up, with the request response thing and whatnot. Let me, yeah. So now, what do we want? Like instead of building different servers, saying that like listen to this, keep polling this, keep pinging this, and what if order microservice fail? What if this fails or this fails, or this went down for some time, and order microservice kept pushing, kept sending that order, this id successful to the server, and this delivery microservice cannot re-establish the connection again. We need to again restart this entire microservice, then it takes this. And yeah, that's the headache part. And same with the notification service. Let's say there is a server here, and this should be listening to this service, and it should ask, are there any requests? Are there any requests? Are there any notifications like successful deliveries? Um, yeah, and if this notification microservice for some reasons fails, uh, again you need to restart this entire service to get what is stored in the server to process the requests. So the term spaghetti means the dependency of each microservice on another microservice, on the way how they communicate is called spaghetti, right? You can see there is so many things, and if you can put, these are like noodles, spaghetti. So yeah, like, but what if I say there is something like central thing, like, okay, I don't know, let's take this. What if I say there is something like this? It's a single server. Why do I do this always? It's a single server saying that, um, second, okay, let me move this down a little bit. Yeah. Now again, let's get all our, now let's get our microservices, right? Not this one. Now let's see our microservices. One, yeah. Let's rearrange them. Okay. 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 Let's move this little bit left side. Yep. Now, rename. We can rename this order service, payment service, order service, payment service, delivery service. Why is delivery service, and let's have here notify service. So yeah, now imagine instead of building each server associated with each microservice, payment service के लिए एक server, this on four servers, and the pain of managing the activeness of these microservices and server is a full headache. And not only that, you should, this server should be scalable, like how many requests you will store in that, and this should be scalable. Same with the four servers. Now imagine this, when you place an order, if the order is successful, when you click for payment thing, what order service does is it goes to payment. My bad, it should be arrow mark. I think this is two. Okay. Okay, saying that uh, someone requested for payment. Someone requested for payment, and payment service will get to know that someone requested for payment, and it takes care of the payment, and it tells that payment is successful. Payment is successful. That the user has paid the user paid, his payment is successful. Now again, the order service will get to know, response, the order service will get to know, okay, now when the payment is successful, it should be sent to delivery service. When some payment comes, this also should route to this, right? Send. Yeah. When delivery service receives that payment is successful, delivery service does the art of finding the nearest restaurant for your food, nearest restaurant that you ordered near your location, and also the nearest driver to that restaurant, so that it will get assigned, and it will say, it will what will delivery service will say? Delivery service will say, hey, delivery boy is assigned, enjoy food. So so after delivery service doing its thing and doing all that, it will say, hey, delivery boy is assigned, enjoy the food. And this is all imagination, right? Like, I'm thinking, like, how does this goes, like, for every request this should happen. uh, how does this work? And if it goes in this way, how is there any headache that we see in this architecture, right? Let's see. uh, okay, when delivery service notifies saying that, hey, delivery boy is assigned, and this sends again notification to notification service saying that, hey, delivery boy is assigned. This will be listening to this, and notification does nothing but notifies to UI. Or another service, if you have, maybe the service which tracks the time and time of delivery and time taken to deliver to your food, or the service which tracks the which tracks the maps, shows that this something, right? But let's cut off here, like, we are not actually implementing this. So yeah, in this case there is no fault tolerance. Like, even the if this service is up, okay, well, let's discuss about this after, because these things are capability of Kafka, and this is Kafka. Yeah, this is Kafka. Kafka is a Why Kafka is called as event streaming platform. Here I have written Kafka is an event streaming platform. This is an event, like when someone requested for order, someone someone placing the order, your order microservice should request for payment, and there is a different service designed for this purpose to specifically serve this purpose, which is payment service. It listens to this event which is generated by order service, and it takes that event that triggered by order service, and it opens the event and it see, okay, order ID, and these are the details. If the payment is successful, that this does whatever payment gateway or whatever it does, and it says, okay, payment is successful. Now once payment is successful, delivery service has to again take this, listen to this event saying that, oh, order ID 123 payment is done. So now it's delivery service duty to take this, the order ID 123, and assign to some of the delivery guys, so that he can pick food and deliver it to the person who ordered it. And it does that all the magic here, and it says, okay, my job is done, and I assigned it to a delivery by so and so, and this is the time of ETA. This is the expected time how in which this will finish, and this sends an event, and notification service which will be listening to this event, that does any orders with any IDs assigned to any delivery boy or not. So it finds order ID 123 with delivery boy named XYZ, and phone number and details whatever, and the time, it takes this. And once notification service uh, get to know that delivery boy is assigned, it either notifies UI or notifies another service saying that, okay, come on, let's go, delivery boy is assigned to you and you will get your food in 30 minutes. This is what is event streaming platform. These are all events. When you trigger, when you, my bad, okay, how to move entire thing to this, to this. Yeah, so this is UI. This is UI, and yeah, this again might notify this, or this can repeat, right? Like this can be keep repeating, and see how beautifully fault tolerant is this. And if you don't have Kafka, you have to handle this. Like this order microservice should send it to some server, and this server should store it, and this payment service should get notified saying that, okay, someone requested for order. Server cannot do that until some server just takes the HTTP request and respond to that, right? Server cannot send it by itself until some request comes. So for that, this payment service has to be establish a connection, and it should keep sending a request. So did someone request for payment? Did someone request for payment? Did someone request for payment? All these requests are waste because there is no response for this. No one requested for payment, and these networks are waste. These all requests with so much of header values and with zero content, no use. It just create a congestion in the network, in the network. So okay, after some time also, if it comes, it picks it up, and again it responds. Again the server should be keep listening to this, and these are all single point of failures. Whatever you see, if one microservice is done, again you have to restart it, and again freshly you need to point to the initial request, because first come first serve, right? If somebody place an order after me, it's not like their order will get processed first. My order should get processed. At least it should enter this microservice. Like maybe depending on the location, I might get, even though I ordered first, depending on the location or the food that I ordered, or so many things, maybe the time or whatever, I might get the delivery late, but point is my thing should get processed first. And if servers are down, you might lose the data and backup. That's a lot of headache, right? And yeah, like this is Kafka. Like you are streaming these events, you are storing these events, and you are doing something with the event, and your this event, the the action that each service does is a food or a consume to this. And that's why there is a producer consumer concept in Kafka, that this is the producer and this is the consumer. Producer produces events. Let me write that. Producer produce events. Consumer consume events. Yeah, like this is the nothing to explain in that. Producer is producing the events and consumer is consuming the event. This, and this is called topic. Topic in Kafka. Imagine something like, Uh, I have not read much about to explain how to imagine or how to relate a topic in a Kafka, but you can imagine something like where it's similar to microservice, right? All requests regarding payment, all events that are triggered from the order service will be coming and sitting in this topic. All requests All responses from the payment service, whether it's a successful or failure, will be residing in this topic. Same with these two topics. While creating Kafka, you can create how many topics and what is the topic name. Yeah, you might ask, Jashan, what if Kafka goes down? Yeah, that I'll explain reliability of Kafka in the next stream when I start reading about the stuff like that. And yeah, the advantage why Fortune 100 companies, 85% of the companies use this is fault tolerant. The number one reason why everybody uses this is fault tolerant, no data loss, and these events, even though it's in the form of like JSON object or whatever, but they are serialized and deserialized. Like they are not stored as like that; they are stored in bits format. Yeah, now I think you understand why Kafka is called a event streaming platform, and why do we need Kafka? We need Kafka to make lives of as easier, like lives of engineers easier, because otherwise you would, I don't know what happens when the load is there on the UI. I don't know how this behaves, and you can also tell Kafka used to communicate between two microservices. What is a microservice? Uh, Microservice is a piece of code that is standalone and does only specific task. Like like if you, I can also make a repo and I can put I can create a folder like order, payment, delivery, and notification, and in that I can write files. And in the main file, I can invoke all these services. That's not a microservice, right? Uh, that's a monolithic. When your payment fail or something, then this doesn't work. So yeah, again that's a debate. Like it became more adaptable because yeah, became more adaptable, and people question like, why do we need microservice? What happens in this? Even I am not sure. I think I should also see about why do we need microservice, because if payment service failed in the monolithic, these two doesn't get what to say, doesn't get to work. Same here as well. If payment service goes down, these two will not get, because this hasn't produced any event, and delivery service will be listening, no events are generated, so it doesn't do any action to generate another event. So same with notification service, and same thing will happen in monolithic also. And yeah, even I don't know why microservices actually came. Yeah, like that, because I got on about microservice by studying what is microservice. If I would have studied, or if I would have read about why microservice, I might have answered to this question. Why do we need microservices? I might have answered to that question. Yeah, I'll do that. uh, yeah, actually this accelerator, I'm gonna bookmark it with the notepad name, where in the streams I can do that. And if I save, if I export to link, and if I copy the link, let me see if I can share it here. Okay, let me open this. Export as image. Okay, this is replace your existing content. Okay, my bad. Yeah, let's. I think that works. If it is not working, uh, French beard. Okay. Yeah, if it is not okay, why to disturb the thing which is already working? So yeah, that is why that is the why Kafka. Wait, let me keep this heading. Let's keep it in caps lock. Right? Why? No, my bad. Why Kafka? And the name is so good, like Kafka. Isn't it cool? Okay. So yeah, this is okay. My bad. Yeah, this is kind of thing like yeah. I think that serves the. Now, if I start telling, I also explored a bit, right? Like, what is topic, what is partition, how they are divided, something. What is consumer, what is producer, how do they, keep track of the events? In that case, what happens if consumer who is consuming events went down for some time and producer produced a series of events? I don't know. Like, I not. It's not. I know it's. I know partially. I need to read about it. But I cannot put the partial content right. So yeah, I think this answers why Kafka. Why do we need Kafka? Now let's how much time it was? It was 40 minutes. How to react to this French beard? Okay, now let's see lead code weekly contest, right? We have two views. Today, how was my contest? It was average, not that good, because there is only one good question that I can do, and I'll tell you why. I solved three questions. As usual, I was unable to solve sixth question. That is because, like, yeah, this I question myself, like, why hard questions um, is hard to solve. Because that's because I think I haven't practiced much hard questions, or maybe if I practice daily some hard questions, I'll be able to think in that direction. So right now, let's quickly do this. Where's the easy question? Like not easy in the sense, no, I'm not judging this question. That's an easy tag question. My bad. So let's see. Let's see what's the problem one. Given a string s consisting lowercase prefix s is called residue. Number of distinct elements in the prefix equal to n more or less 3. This is very like okay. Given a string s, uh, for every prefix string starting from 0th index, if number of unique chars in that prefix is same as length of prefix modulo 3, count this and return how many such prefixes are there. This is simple, uh, like I can no need to explain. Create a, first I was thinking, I couldn't read the question right. I thought I didn't see the distinct characters. I thought in the prefix I thought distinct characters of whole string. So that's why I created a prefix count, and yeah, it's like messy. I got when I ran it failed for ABC itself, and no, it failed for DD, and then I have to recheck my logic, and yeah. So yeah, create a set, and for each character of this, add it to that. Whenever, uh, whenever you have unique characters, which is same as what actual. So let's say if you are at I, what is the length? I plus one. That is also a basic thing, and this is nothing but what this line is just what he told, what they ask in problem, and I'm incrementing the count, and then you return the count. Should be simple one. We'll quickly go to second question. Number of centered subarrays. This is tagged as medium, and yeah, like okay, we'll go to problem two. I think I know this question. Given a array nums, find number of subarrays such that sum of subarray elements is equal to at least one element in that subarray. Return the count of such subarrays. This also looks simple, but you should more concentrate on, yeah, again, like I didn't wait, what? Okay. Yeah, I did it using brute force. Even I had in the contest because of some time pressure. I couldn't think about optimal because if you see the constraints also accepts two for loops or whatever n square. But that's why this question has 65.5 rate. If you see, I think everybody, maximum of the people who attempted this question, like this 37K or this 24K, those guys have done would have done like me how I did. But there is one observation. I need to absolve this today, but there is one observation that I did. So there is A comma B comma C comma D. So if sum of A plus B plus C plus D is equal to A or B or C or D, what does it implies? Uh, then except that element, remaining sum is zero. So except that one, except the sum, except the one element, remaining sum of elements in that subarray is zero. And we have seen you might have done questions like how to how to find if something subarray, if sum of subarray is zero, and you might draw some observations from that. And this is the initial thought, like very um, st- I don't say straight thought, very vague thought that I got, and I need to work on this to see uh, what actually, and this is towards the optimal solution, right? But luckily it got accepted because of the low constraints. See any comments? Nope. I think someone is watching live. Okay. Uh, let's go to okay. Let should I see topic? It will be nothing. I see hint one. Generate answer respect to just from generate answer. I think yeah. Some I should. This is not a hint. This is just for. Uh, this is for the brute force one. Instead of using here, I use the third for loop to check um, if again from I to j, if there is a element which is equal to some, then I'm breaking and I'm incrementing the count. Instead, what you can do, you can pre-populate the map and you can check here if map dot contains that, and yeah, it doesn't make much difference because it's not higher constraint questions, hard constraint questions. This is a very good question. I like this question. Count Caesar cipher pairs. We'll see the question. I don't want to waste more time on writing the question. So I'll just copy this right from here to here. Yeah. And here is the example. So if you take fusion, if you keep incrementing one to all the characters, and if you keep doing this, at the end of the this, you will find, you will reach this word, and if you find, you need to return how many pairs like that. So let's take this array. If you add plus one to this, AB become BC. If you add plus one to this, AA will become BB. If you add plus one to this, ZA, Z will become A and A will become B. And AA will become BB and things like this. And what will be the answer? So if you take for AB here, uh, if you increment for like, if you increment by one ZA, you will get AB. So this is one pair, and if you increment AA by nothing, you will get AA again. So this is one more pair. Here they written, right, they mentioned you can apply the following operations any number of times, probably 0 times. If I apply for 0 times, this will be same. So now, yeah, what to do? How to solve this? I first when I see about this, when I saw about this, I thought something like this. So create a m cross n matrix which says that each like how many number of words and length of each word. So you will get the ASCII values of at that word and what is the character of that value. And in order to make two rows will be equal in that, right? So if you make like this, if you populate like this, and we need to show, somehow show if two rows are same upon doing some operations. If two rows are same upon doing some operations, then this is answer, probabilistic, like basic answer. And but how do you come up with this? So what you can do is, um, for a row I and row j, for each column, no, for each character in these two rows, for each character in these two rows, if the difference between the two characters in the two rows is same, then we got answer. Like, for that what you can do, so let's say diff equal to uh, row of I column minus row of j column, absolute value, no, absolute value, no need, no, yeah, no need to take absolute value, it will be positive or negative. So now sum of these differences should be equal to each difference into how many columns are there. So n, difference into n, where n is length of each word, because it's, you are adding it up on this. And if this is satisfied, if this is satisfied for each any of the diff, like maybe for the first diff itself, then yeah, I think we found our two rows, we can increment that. But this, you are ultimately iterating from, for each row, for each two rows you have to do, and you have to pick two rows and you have to do some operations. So for picking two rows, it will be big of n square. For picking two rows, it will be big of n square. For each column, you need to do the operations for each that two arrays, right? So it will be big of m, and total will be big of n cube. You will easily get timeout error in this, because if you see constraints, the constraints are very high, 10 power 5, 10 power 5, both are 10 power 5. And very quickly, if n into m is reaching 10 power 5, n into m into n, again multiplying 10 will become 10 power 10, you will lose this thing. So this is not possible. This is not possible, and I didn't even try to implement this, because when you come till here, you will realize that this will not give you the correct, this is not a correct approach, and it will give TLE. Now there is one possibility left, there is only one possibility left, that you did the difference between the vertical things to each letter of this and each letter of this. Another thing you can do is compare horizontal wise. If difference between characters, sorry, my bad, if difference between characters in string A is same as difference between characters in string B, then count it here, count plus plus, increment the count. And you might think, but you might also think like we need to take two characters and do this always, but it's not the case. Like for example, what you can do is you can uh, create some immediate string like this. Sorry, my bad. For int I is equal to 1, I less than s dot length I plus plus. What you can do is you can calculate the difference. Int def will be s of I minus f of I minus current minus previous character string s dot append. Keep appending the difference and some character, right? Maybe the underscore or whatever, like whatever you like. You I while context while attempting this, I appended with underscore. You can append with anything, maybe question mark or whatever. So let's say for a string fusion, we got 3, 2, 5, 4, 1. We got this. And if we do this for some other string, we got this 3, 2, 5, 3, 1. What does this tell? This tells how does the difference between the characters remain same. That's because if the first character is incremented by how many number of times, the second character also would be incremented by the same number of times. So if AB difference is 1, increase AB by 6 each. So A B C D E F G, you'll get H. Again, differences between these two is 1. That is because these two characters are incremented by same amount. By same value. No need to add amount. There is incremented. Okay. Yeah. So yeah, what you can do for this is create a map. Uh, of string comma of intermediate string comma number of such intermediate string for the same value. If I process the string AB and if I process the string GH, since this one okay, let's take ABC and ABC GHI. Let's take ABC and GHI. For this string will be 1 underscore 1, and for this string will be 1 underscore 1. In the map, it should be 1 underscore 1 is mapped with 2 because two such strings appeared. Something like that. And yeah, what you can do is uh, so for each string now. My bad. No, what they are asking in total how many such pairs are there, and what you can do is you can iterate through this, and you can get the answer. Add these, and you will get the answer. Actually, you should not add this. What if you see? I added all this, and I actually didn't return this. I just added uh, answer plus equal to val, and I got wrong answer in this words. If one after running, I didn't submit the code. Usually I don't submit the code until these basic test cases passes. So yeah, uh, this is wrong because if you see this constraint, I should be for such pairs, for such indices I comma j, I should always be less than j. Like the word 1 should be in the left side and word 2 should be in the right side. So you can ask me, but why is this? Why is this not val into val minus 1/2? So say this comes probability, no, not probability, permutation and permutations and combinations. So we have n. We need to pick only two. Why only two? Why we cannot we pick more than two pairs? Because there exists only one. There exists Only one pair which satisfies this I less than j. There exists only one pair out of how many number of pairs you have. Let's say if you have four, and out of four you need to only pick two. Why only two? Why not more than two? Because there exists only one, and out of n we need to pick one. So it is nc2, which is n into n minus 1 by 2. So keep incrementing the values for each map dot values and return that answer. And yeah, we are good. We are good to go. We got the answer. Yeah, this is one good question I can tell in today's contest. Even the second question is good, but I since the contests will be time oriented, I couldn't come up with the optimal solution. I need to absolve it maybe today or this week. So yeah, um, again, like do not worry about like how others are doing in the contest, and I'm not able to do in the contest. Doesn't matter until and unless you are able to solve specific number of questions. So yeah, uh, yeah, I think yeah today it's a good stream. I enjoyed this one. Today I enjoyed this stream, and even this Kafka one is good. Let me try to save this so that I can. If I save to disk, how can I? Okay, let me let me copy this link and paste somewhere, and not here, and paste it here. Yeah, I will share this link post the I'll end the stream so that you can just see this like the architecture and stuff like that. Yeah, that's it for the stream. I am ending the stream. Thank you.